In this video, we are going to be learning how to get the equation of straight lines which are parallel to the given lines. Now we start with this example. Find the equation of the line passing through the points minus 2, 3 and parallel to the line y minus 2x plus 4 equal to 0. Now the first thing we are going to do is we are going to write out these points given minus 2, 3, and of course we'll name that x1, y1, right? Then from this equation, we are going to relate it to this form, y equal to mx plus c. Now, why is this important? That is because parallel lines have equal gradients or slope. The slope of parallel lines are equal, or the gradients of parallel lines are equal. So when we get this equation of an already existing line in this form, then we can now use the method of when you're given a gradient and a point of a straight line, you can as well find the equation of that line. Now, there are still other methods of solving this, but I want a method that already aligns with what we've been learning previously. Okay, so this equation, y is already positive on this side, so we are going to send every other thing to this other side of the equation. Now, in this equation, we have that y is equal to minus 2x crosses over to be 2x, and then plus 4 crosses over to be negative 4. Therefore, the gradient of the line is equal to 2. Good. So, having the gradient of the line, we have that gradient of the line is equal to y minus y1 over x minus x1. So this is the formula we are going to use to find the equation of the line which is parallel to this and passes through this point. Now let's dive in immediately. So the gradient is 2, y minus y1 is 3 over x minus x1 is minus 2. Now we have that 2 is equal to y minus 3 over x plus 2. We cross multiply, and multiplying gives us that 2 into x plus 2 is equal to y minus 3. We now have 2x plus 4 equal to y minus 3. Now, before we can rearrange this, now let's look at the equation given to us. Always try to give a similar equation, an equation that looks like the one given to you. So we see that y comes first, right? So because of that, let us send everything to this side and then equate it to 0. We now have y, then 2x comes to be minus 2x, and then we have minus 3 already here. Okay, let me write that. Then plus 4 comes over to be negative 4. Then we can now equate it to 0. Now we finalize this equation by saying y minus 2x minus 3 minus 4, that is minus 7, equal to 0. So this is the equation of that line, which is parallel to this other line and passes through the points, this. So we can see that the equations look similar. The only difference is the constant, and that is how we know parallel lines. The equations has to be the same for x and y, and then the only difference is in the constant. That is why they are parallel lines. Now on to more examples. Find the equation of the line which passes through minus 3, 5 and parallel to the line 3y minus 5x plus 2 equal to 0. Okay, so the first thing we do is we write out this point minus 3, 5 and then name that x1, y1, and then we rearrange the given equation to the form of y equal to mx plus c. We now have, so we leave the 3y on this side equal to minus 5x crosses over to be 5x and then minus 2. We divide all through by 3. We now have that y is equal to 5 over 3x, and then this becomes minus 2 over 3. So from here we have that the gradient is equal to 5 over 3. So seeing that the gradient is 5 over 3, we now come to this formula that the gradient is equal to y minus y1 over x minus x1. We have that 5 over 3 is equal to y minus y1 is 5 over x minus x1 is negative 3. So that gives us plus 3, right? So we cross multiply, we have that 5 into x plus 3, that is when we've done this, is equal to 3 into y minus 5. We open up the brackets, right? We now have that 5x plus 15 is equal to 3y minus 15. Now, before we collect the terms together, let us look at the original equation given to us. So it starts with y, right? And then everything equates to 0. So that's the same thing we are going to do here. Now, since the y is already on this side, let's collect everything to this side. So we have 3y is already here. The 5x crosses over to be minus 5x. And then the minus 15 is already here, right? And then this plus 15 comes over to still be minus 15. And then we can now equate it to 0. So we now have that 3y minus 5x minus 15 minus 15, that is minus 30, is equal to 0. So now we compare the two. We can see they look alike like parallel lines should. The only difference is in the constants. Now, before we go, let's do an application question. Two straight lines are 3x plus 2y minus 5 equal to 0 and x minus 2y minus 7 equal to 0. Find the equation of the line through their point of intersection and parallel to this line. So whenever we hear that these two equations have an intersection, that means we are going to solve these equations simultaneously. And then that point of intersection is what we are told that is parallel, that we should find equation of the line that passes through the point of intersection of these two lines that is parallel to this. So when we solve this equation simultaneously, we are going to have a coordinate point for x and y. So that is the coordinate points we'll now be solving with this. Okay, now let's solve the simultaneous equations already. We have that 3x plus 2y minus 5 equal to 0 as equation 1. We have x minus 2y minus 7 equal to 0 as equation 2. We can use the elimination method. We can already see that these two are equal. So we have to, not subtraction. Since the two equal components of coefficients of y have opposite signs, so we have to add up. So that this plus minus becomes minus. So plus minus something equal to each other becomes 0. So we can eliminate y. 3x plus x is equal to 4x. Then this 2 gets us 0. We now have minus 5 plus minus 7, that is minus 5 minus 7 is giving us minus 12 equal to 0. So 4x minus 12 equal to 0. We can as well turn this over to this other side so that we can solve for x. We have that x is equal to 12. We divide both sides by 4. We now have that this gives us that x is equal to 3. Okay, seeing that x is equal to 3, we can substitute that value into any of the equation. I pick out equation 2 to substitute the value for x and then solve for y. So this gives us that instead of having x, we are going to have 3. So from equation 2, From equation 2, we have that 3 minus 2y minus 7 is equal to 0. So we collect these like terms. We have that minus 2y. 3 minus 7 is minus 4 equal to 0. Now let's send this over to this side. Minus 2y is equal to 4. We divide both sides by minus 2. We have that y is equal to 4 divided by minus 2 is minus 2. So the coordinate points are, first of all, the x value 3 and then the y value negative 2. So this is the point of intersection of these two lines. So with this point of intersection, now let us solve for the parallel equation to this. So now we have these points. We have it as 3, minus 2. We name it x1, y1. And then the equation we are interested in is x plus 2y minus 5. Now let's rearrange this equation to be in the form of y is equal to mx plus c. Okay, we have that 2y is equal to minus 5 crosses over, okay, let's have it x crosses over to be negative x, and then this becomes plus 5. We divide all sides by 2. We have that y is equal to negative 1 over 2 of x plus 5 over 2. So this is the gradient of this line. We have that m is equal to negative half. And then these are the points of, this is the point we are interested in passing this line through. So we have that m is equal to y minus y1 over x minus x1. Then this gives us to, when we substitute, we are going to have negative 1 over 2 is equal to y minus y1 is negative 2. And then x minus x1 is 3. We now cross multiply. When we cross multiply, we are going to have that negative 1 into x minus 3 is equal to 2 into y. It becomes plus 2 because minus minus gives us plus 2. We open up that bracket. We have negative x plus 3 is equal to 2y plus 4. Now, before we rearrange this equation, let's look at the equation we are interested in. That is this equation, right? So we can see it starts with x, and then we have a y value, and then it's all equal to 0. So now it starts with a positive x, therefore we send it across to this side. We send everything to this side. We now have that x on this side becomes positive x. 2y was already there on this side, and then we already have a plus 4 here. This plus 3 crosses over to be a minus 3. So this gives us that x plus 2y, 4 minus 3 is equal to 0. So this is the equation of the line that will pass through this point of intersection and is parallel to this line given in the equation. So we have learned how to calculate for that is how to find the equation of a line, of a parallel line to a given line when we find a point it passes through.